Hi, how is everyone? I'm Guido and I'm a big fan of Chrome V8. I hope this video will be useful to you. I would like to share more V8 experience with you. Please shoot me without hesitation. In this video, I would walk you through the compiler and give you a sense of how it works and how a JavaScript function translates to AST and bytecode. And I don't talk about the optimizing compiler Turbofan this time. Okay, let's go. Let's go into the compiler. I don't talk about the streaming compile. I want to keep your eyes on the important part, as there's too much stuff to learn. Going to compile. This function compile unbound internal. What it means unbound? It means the bytecode doesn't bundle with a context. Namely, the bytecode can't be executed yet. Step into it. We step over the trace profiler. Here, there is no consume catch, so we would go here. Before I advance, I explain what the shared function is and what important number it has. Roughly, we can assume the shared function is a Windows dynamic link library. We know the DLL is a binary code library that needs to be loaded before executing. Similarly, the shared function needs to be bundled with a context before executing. In a shared function, the important numbers are bytecode array and offset, in which the offset gives the correspondence between bytecodes and the JavaScript. Okay, step into over. These lines are not important. Here, it's language mode. Here, the parser info is a container that manages the input that is your code, configuration, and the AST tree. Here, start compiling. Step into it. Here, it's going to parse our code and generate AST. Let's go into here. The parser program. Skip into initialize. The compiler workflow is to scan tokens and then translate the tokens into an AST tree using the parser. In V8 implementation, the parser starts up first and takes out the tokens from token cache. When the token cache misses, the parser calls the scanner to work. So this is the reason why there is only scanner initialize but not scanning, because the scanner doesn't work until the parser calls it. Note that the initialize will scan one token, as the parser needs one token to start up. Let's going to do parser program. Here, the result is an ASC tree that the parser generated. Step over. Here, it is parsing statement. Let's go into it. See here, peak checks the current token type. The current token type is just the one that was generated in the scanner initialization I mentioned up front. What type the token is depends on your code. Let's go on. Here, go into it. The lines I select are telling us how working the parser is. The switch case is a finite state machine actually. Yes, the parser and the scanner are implemented using the finite state machine. If you are interested in it, debugging it yourself, but I don't go into it more depth as there are many recursions. Okay, return back to parser. Okay, here we got the AST corresponding to our code.